Okay, 6.5. We're going to solve polynomials with long division. So here I have x cubed minus x squared minus 2x plus 8. And I'm going to divide it by the polynomial of x minus 1. So long division means we're going to set this up with the x minus 1 on the outside. We're going to put the other one on the inside. When we set these up, we need to make sure that every position is accounted for, meaning cubed, squared, single, no x. Everything has to be there, or you have to make a position for it. All right, when we do this, we only look at the first term. So I'm only looking at the x and the x cubed. And I ask myself, how many x's go into x cubed? Well, until we get better at this, you could set it up, x cubed divided by x. How much is that? And you should come up with x squared. Now that we have, we know how many times it goes into, we have to multiply around. Just like in grade school with long division, whatever goes up here, you multiply it around and then subtract. Same idea, except for when we multiply, you have to make sure that you are multiplying to everything. So this is x cubed minus x squared. So I distribute, and that's where these pieces come from, x squared and x squared and 1. And then I subtract. Now when I subtract, I need to make sure that I subtract all pieces. And what that means is that I switch my signs. The first one goes away. It always goes away. If it doesn't go away, you did something wrong. It has to disappear. Now the second one is just coincidence that they cancel out. Everything else comes down. And now I focus again. First term, first term. So what's negative 2x divided by x? Or how many x's go into negative 2x? We get negative 2. When I distribute, I get negative 2x plus 2. Negative 2x plus 2. Now when I subtract, I change my signs. First one goes away, it has to go away, or I did something wrong. And 8 minus 2 is 6. And I try it again. 6 divided by x. Well, x does not go into 6. Therefore, it's a remainder. And just like, remainders from the past, we put them in our problem, and we're going to always use a plus sign. The remainder, so in this case 6, over the divisor of x minus 1. So that's our solution. X squared minus 2 plus 6 over x minus 1. Okay, let's look at y4 plus 2y squared minus y plus 5 divided by y squared minus y plus 1. When I set this up, the divisor goes on the outside, the dividend goes on the inside, but every position must be accounted for. So because there's no cubed, I have to put one in. Whether I use it through the problem or not, I have to always consider that it's a possibility that it's there and I need to have a position for it. Okay, now I look at the first terms. Y squared, y4. So how many squareds go into y4? And hopefully we know that to be y squared. When I multiply, I need to make sure I multiply to everything, and I need to make sure I line it up to its proper. So y squared is y4. Y squared negative y is negative y cubed. Y2 and 1 is y2. Now when I subtract, I switch signs. The first one goes away. It has to go away or you did something wrong. And now I get y cubed, y squared, and the rest comes on down. So I start first term, y cubed divided by y squared is y. Multiply around, make sure I line it up. So there's going to be y cubed minus y squared minus y. When I subtract, I switch signs. First one goes away, it has to go away. Coincidence, the third one goes away. And now I look at the first term and first term. How many y squareds go into 2y squared? Hopefully I come up with 2. Multiply around, I get 2y squared minus 2y plus 2. When I subtract, the first one goes away. Second one becomes 2y. And 7. Okay, then I ask myself, alright, I need to go back and I made an error up here. This should have been when I multiplied and I got positive y, so it was positive. So when I switched the sign, it became negative. So that this was 2y squared minus 2y plus 5. I still multiplied by the 2, so I got 2y squared minus 2y plus 2. When I change my signs, the 2y squared goes away, the 2y goes away, and I just get 3 left over. 3y squared does not go into it. 3 does not go into y squared. So 3 is my remainder. So I put plus 3 over my divisor. And that's my final answer. Alright, so we're going to do several of these in class and get a little bit more practice with those. But that's the first part of 6.5 where we're going to solve polynomials with long division.